Hello everyone. So this is the second part of our tutorial on how to optimize a DC resistive circuit. So in the previous video, I have stopped at the optimization procedure. So now I will start from the beginning, that is from the simulation procedure onwards. So before that, we have to do some changes. That is, in the previous video, we have noticed that the voltage and current is negative. This is due to the polarity of the voltmeter and ammeter. So we can say that in basic circuit params file, we have ammeter and voltmeter. So polarity of ammeter, that is the positive polarity of ammeter is towards 15R and voltmeter is 18N, which means in our circuit this is the positive polarity 18N, and for ammeter this is the positive polarity, that is 15R. Since we are getting negative of current and voltage, to make that positive we have to change the polarity, which means for voltmeter we have to change the polarity to 18P, and for ammeter we have to change to 17R. So now we have to change the polarity in the params file. So go to params file. So here we have to change the polarity of meter and voltmeter. So for ammeter we have to change from 15R to 17R. And for voltmeter you have to change 18N to this position, that is 18P. So now we will get positive current and positive voltage. Now the other change we have to make, that we have global file.py. Open that. Here we can see that we have diagram array, params array and output array. We have changed the diagram array to basic circuit, which is the name of our circuit. Now we have to change this params array, which means we have to write the params file corresponding to basic circuit. So for basic circuit, the params file is basic _ circuit _ params.csv. So we have to replace this name by basic circuit params.csv. So we have to change these names. We should be very careful while writing the name, don't make any spelling mistake. And in the output array, this is the output file where the output data is stored. This is already we have changed to circuit output 1.data and circuit output 2.data, and it is default. We get these names here, so we do not have to change, and we have given in the circuit inputs that we have to split the output file, so we do not make any change. So we have to change this params array to basic circuit params.csv. And why there is 3 arrays here? In this simulator, if the circuit is very complex and large, it will be difficult for the user to draw a single circuit in a single Excel file. So to avoid that difficulty, we can split the circuit and we can draw the circuits in more than one Excel files. So while doing like that, for each circuit file there will be one corresponding params file. So here we have only one circuit file, therefore we have only one params file. If more than one circuit file is present, we will have more than one params file. So we have to write in the order here. Now we have only one, so we have to we don't need to write more than one name here, and it will be more clear in the future tutorials. one more change we have to do is in the circuit inputs.csv. Here we can see that we have given the time step of simulation and time step of data storage as 1 microsecond. If you give 1 microsecond, it will take more time for the simulation. So it's your choice. For now, I am changing this to 1 e minus 2 for both the cases, so that the simulation will be fast as well as the optimization procedures also will take place very fast. So I have changed the two data, that is time step of simulation and time step of data storage, to 1 e minus 2. You can see that. Now we can go to mainframe, and now all done, we have made all the changes. Now we can start the simulation. So now we have to run the mainframe. So click run. You can run from here by clicking this button. So simulation has started. So as you know, circuit inputs has been found. So we have filled it already before. So we can proceed by pressing Y. Now it will ask whether we have to keep the old output file, that is old circuit output 2 dat and old circuit output 1 dot dat. So we don't want that. We should have a fresh file. So we can proceed by pressing N. Now it will say that a params file is found and we have to enter the parameters. We have already entered the parameters in the previous video. You can see that here all the values are default 0.001 for all, and so one thing we have to do is, so here we are going to optimize the circuit. You know, this is our circuit, so we have to optimize the circuit. So here I want to optimize the voltage across the resistor R7. So I want to get a particular voltage across the resistor R7. So consider R7 as our load resistor. So load resistance means there should be a value. So here the value is 0.001. So let's consider the load resistance as 200 ohms. So we have to change to 200. So now the R7 resistor is having 200 ohm resistance, and I want a particular voltage. Suppose say I want 120 volt across this resistor, which means the voltmeter should read 120 volt across this resistor. And for getting 120 volt, what should be the values of other resistors? That's what this software will tell us. So here I have changed to 200 ohms. So now we can proceed by writing yes. So type Y and proceed. Now the simulation has completed. This is very fast simulation because we have changed the time step of simulation. And we know that first value represents the time, second column represents the meter, the third column represents voltmeter. So we can open the output file. There are two output files, 1 and 2. So why we had no two files here is that for every circuit there will be a transient state and steady state. So here the circuit output 1 dot dat will have a transient state. All the values during the transient state will be stored in this file, and all the values in the steady state will be stored in the second file. So this is the second file. So here we can see that this is the time, this is the current, and this is the voltage. Now we can see that with R7 200 ohms and all other resistors with 0.001, we are getting 44.7 volt. And you can also notice that the current and voltage now has changed to positive value. So now we can continue our simulation. So it is asking, do you want to prove? For now we are not proving, since I have told you how to prove this in the previous video. So I am proceeding with no, that is N. Then it will ask to compute any values. So here I am not computing, so I am giving N. Now the optimization procedure is starting. So from here the optimization procedure is going to start. So let's start by typing Y. Press Y to proceed. So it will ask which feature do you want. So 1 for optimization and 2 is topology change and optimization. So topology change and optimization is a feature where we can change the position of our elements and we can optimize the elements of the circuit together and we get the required result. So now I am not going for that. Now I want the optimization option. So proceed by pressing 1. And you will get more idea about the second feature in the future tutorials. So now it will ask, enter the number of elements to vary. Number of elements to vary means, you know that this is our circuit. So R7 is our load resistance, which is 200 ohms. And we have other resistance here, that is from R1 to R6. So not R6, we have R8 also and R9. So there are 9 resistance. So we can see that R7 is our load resistance and we have other 8 resistances. So we cannot vary the R7 because that is our load resistance, it is constant. So we have to vary the other 8 resistances here, that is from R1, R2, R9, R3, R8, R6, R5, R4. So that is what they are asking. How many elements we want to vary? So here I want to vary all other resistances. So excluding R7 there are 8 resistances. So I am giving 8. Now we have to specify some parameters. So here we can see that how to specify. The format of specification is given here. That is, first we have to specify the element number, comma, element row number, comma, maximum value and minimum value. So element sheet number means we have to go to the global file. Here we can see that the diagram array, we have only one file, that is basic circuit.csv. So our circuit is basic circuit.csv and our elements are present in this circuit file. So here we should give 1. So 1 corresponds to element sheet number. Now we have to go for comma, element row number. For getting element row number, we have to go to the parameters. Here we can see that starting from 1. So for first row, that is R4 is in the first row. So let's start from R4. So we have to give 1. Then we have to go for comma, then we have to type maximum and minimum value. So let's give maximum value as 1000 ohms and minimum value as 0 ohms, which means we should get a value between 1000 ohms and 0 ohms for the resistor R4. Now we have to press enter. Now it will ask the other specification. So now I am giving for second resistor, that is R9. I am giving the sheet number is 1, comma, now the row has changed because it is in the second row. So we have to type 2, comma, 1000, comma, 0. Here I am giving 1000 and 0 for all the resistors. No percent. Now it will ask for the third parameter, third resistor. So I am giving 1, 3, 4, 5, 0. That is, this is the third resistance R1. Now we are going for 4, 5, 6. So I am typing for all the resistances now. After 6, that is after R6, there is 2 resistors, that is parasitic resistors, that is 7 and 8. So these are parasitic resistors. We don't need to change these resistors. So next resistor is R3, that is 9. So the row number has changed. So from 6 it is changing to 9. Maximum and minimum are same. Now the last resistor, the 8th resistor, that is 10 we cannot change, that is parasitic. Now 11, that is now 8. So for R8, 1, 11, 1000, 0. So 11 represents the 11th row. And this is 12. 12 is 200 ohms, that is our load resistance. So we have ended all the 8 resistors. Now we can proceed by pressing enter. Now it will ask, do you need to vary control variable with the algorithm? So this control variable is an extra feature here. We will explain this in the future tutorials. So now we don't want this feature. So proceed by pressing and enter. Now it will ask what all parameters or what all output parameters we want to optimize. So as I told, we want to optimize the voltage here, that is the voltage across resistor R7. So I have to optimize only one parameter, so I am giving 1. So these are the functions available. So for voltage, what voltage? The average voltage, triple voltage, RMS, or peak voltage, like that. So here I want to optimize the average voltage. So I am selecting option 1, that is type 1, and press enter. Now it will ask enter the output file number. As I told, we have 2 output files. That is in the global file we have 2 output files, 1 and this is 2. So for which voltage you want to optimize, that is in output 1 or in output 2. So I want to optimize in the second file, so I am giving 2. So 1 for circuit output 1 dot dat and 2 for circuit output 2 dot dat. So I am giving 2 here. Proceed with enter. Now we want to give the meter number. So for getting meter number, we know that after simulation you can see here 3 rows, and I told 3 represents 4 voltmeter readings. So in here we have to give 3 because 3 represents the voltage. Now we have to specify the maximum and minimum output voltage. As I told, I want 120 volt. So here I am giving 120 volt as the maximum value, minimum value as 115 volt. So that we will get a value between 120 and 150. So I have given maximum value as 120 and minimum value as 150. So now we can proceed by pressing enter. And it will ask for whether we want to add any constraint. So this is also an extra feature and we will discuss about this in the future tutorials. So now we can skip it. So press N and proceed by entering enter. Now it will ask for enter the number of iterations. So this will ask, actually this feature is how many times we have to run the optimization algorithm to reach our desired output. So here I am giving 1000, which means the optimization algorithm will run for 1000 times to get our desired output. So now we can proceed by entering enter. Now the optimization procedure has started. It will take about 2 to 3 minutes. Since this is a single circuit, we can run by 1000 iterations. If it is a large circuit, we have to go for more than 1000 iterations. Then only we get the correct output. So let's wait for the result. So now we can see that the optimization procedure is over. We can see that there is the objective error and the objective current value. So our current value is 117.5 volt and the error is 2.11 E minus 7. So as I said, I have given 120 volt and 115 volt as the range, but we have got 117.5 volt. Now you can see the output file as by opening this circuit output to that. We can see that the current is 0.5 ampere and the voltage is 117.5. Since we have given the range between 150 and 120, we have got 170. If we give range between 120 and about 190, we will get another value. So we have got 117 volt as the voltage across resistor R7. We can see the params well as we can see that the resistor R7 is having 200 ohm itself, and now we can see that all other resistors have a value now. Look, for R4 we have 21.1, R9 136.6. So if we use the resistor with these values, we will get a voltage of 117 volt across the resistor our R7. So across the load resistor we will get 117 volt if we use these resistors with these values. And after the result, a feasible.txt and non-dominated solution.txt will be generated. If you open this file, feasible.txt, we can see the solutions. So these are the different solutions. So here we have got 10 solutions. And in each solution we have the values of the resistor. We can see that there is only small changes in the resistor values. So we can choose any of these solutions. So if we choose any of these solutions and use these values of resistors, we will get the output voltage as 117 volt. So this is what iSoftware does. It will give the values of other resistors, and if we put these values in our circuit, we will get 117 volt. And we can also see that here we have got 0.5 ampere and 117 volt. And also one more file is created, that is non-dominated solution. Here we can see a solution here. This is, if we put these resistor values, we will not get the output as 117 volt. So we will get two files, one is feasible.txt and other is non-dominated solution.txt. So we have to check feasible.txt because it has the solution, solutions which are feasible. So the optimization procedure has over, and we have got the resistor values here. Also we can take the values from here also. We can choose any of the solutions. So now we will think that whether we can optimize the current. Yes, we can also optimize the current also across the resistor. But one thing we have to remember is that voltage is proportional to current. So we cannot optimize both voltage and current across a resistor. Either we have to optimize voltage or we have to optimize current. So here I optimize voltage. You can also optimize current. While optimizing current, you have to change the meter number only, and you have to specify the range values for current also. That is, here I have given voltage range as 120 and 115. You can give current range between any value, that is 1 ampere to 0.5 ampere or 1 ampere to or 2 ampere, between 2 ampere and 1 ampere, like that. So that's it. So I am ending this tutorial here. So see you all in the next video.